Okay, so on this one, it's asking us to find the vertex, focus, and directrix for this parabola. So they're giving us a parabola, and they want us to basically find all the stuff. How do we do it? Again, it's all about the notes. So if you look here at the notes, you first thing you got to figure out is whether it goes up or right, left, up or down. You know, which way does the parabola open? Right, left, up or down? How do you figure that out? Well, looking at those four graphs I've given you right there, what we need to realize is that it's all about the right side, or I shouldn't, it's not always the right side. You can switch that. It's the first power letter side that determines the direction. Do you see that? If this is first power over here, positive 4ax, then that's to the right. Positive x, see? Positive x is to the right. Because what's tricky about a parabola is one side has a second power letter, the other side has first power. So that's why I'm telling you, it's always the first power letter side that tells you the direction. If the first power is positive x to the first, that's right, because the positive x-axis goes to the right. If the first power side is negative x, then negative x, that goes left, like the negative x-axis. If the right side, first power side, is positive 4ay, well, the positive y direction is up. The parabola goes up. If the first power side is negative 4ay, then that's going to go down because negative y is down. Okay, so it's all about that. What do we have? Oh, and I forgot I should have done the first step. First step, get x or y squared alone, factor out 4 or negative 4 from the other side. Factor out 4 or negative 4. So let me do that. I need to do that. Y squared factor. So we get to 16x. You've got to factor out 4. 4 times what? 4 times 4. Right? That's my a value. Now I know that might seem weird. Like, why are you factoring out 4? That's just exactly what it takes to make this work. So whatever they give you on the right side, you have got to factor out a 4. So if they've given me 20x, I would have factored out a 4 and it would have been 4 times 5, etc. So whatever they give you, you pull out a 4, but don't change it. 4 times 5 is still the same as 20. 4 times 4 is still the same as 16. I haven't changed it. It's still the same as it was. I've just pulled out a 4, factored out a 4, haven't I? Okay, so now that's the first step. And the second step is to find the direction. Which way is this one going to go? Well, this is positive x on the right side. So ours is going to go to the right, right? It's like this right here. The right side is positive x to the first power. Goes to the right. See that? Positive x to the first power goes to the right. Okay, I'm going to draw a graph of this one, even though they're not requiring a graph, it'll be helpful. So let me do that. Okay, so here comes the graph. Now it's going to go to the right. So we know there's branches basically going like this. I don't know the specifics yet. I'll just put that down just to help me kind of get going. You know what I mean? We know it's going to the right. So, well, actually, I better erase that because it's not exactly perfect. So we're looking like this, right? We're looking like this. We're going to the right. So now next I need to find the focus point. If you look at the steps, oops, sorry, I keep changing my mind. Down here, find the focus point. Always inside the branches at a distance a from the center. So the focus point, you can see it right here. See this F, this focus point? See how it's inside the branches at a distance a. See this a here? This distance a from the center. What's a? This is a. Remember, that's why we factored out that 4. A is the number next to the 4 we factored out, which a also happens to be a 4, coincidentally. Right? A is the number next to the other 4, which is also a 4 for me. So I'm going to go 4 to the right. Why to the right? Because remember, the branches go to the right. And the focus point is always inside the branches. See it right here? Focus point is inside the branches. And that's what it says down here in the instructions. Focus point is inside the branches, A from the center. So it's right here. inside the branches at a distance A from the center. So you go, okay, so the focus point's right there, 4 away from the center. So this must be over 4 of 0. So the focus must be over 4 of 0. The vertex is a fancy word for center. That's going to be 0, 0. This one's centered at 0, 0. There's nothing to shift it. I'll show you one in a little bit where we shift them, but this one's centered at 0, 0. Okay. And let's find the equation of the directrix. So what's the equation of the directrix? Well, that's going to be right behind it. Let's go back here again. This right here is dotted line. Remember, dotted lines on a graph mean they're not really part of the graph. They're just there like a guideline kind of guiding the graph. Directrix lines are a little bit different. They really direct it from behind, kind of like a director directs a movie. You don't see the director in the movie. He or she just directs it. Well, that's kind of what a directrix line is like. It directs the parabola. Anyway, so we need to put it on there. So where is it? It's always behind, whereas the focus point is inside the branches. See how the focus point is inside the branches, directrix line is behind. Same distance for both the focus and the directrix line. It says that right down here in the steps. The directrix line always behind the branches at a distance A from the center, just like the focus was A from the center. That's why that A is so important. It tells you how far to the focus on one side, how far backwards to the directrix on the other. And so the directrix line, again, right back here, A. So the focus point is here. Here's the center, 0, 0. And then the directrix line is going to be back 4 right there. Oh, well, it's not a point. I just messed up almost. It's not a point. It's a line. At -4. And so there it is. Again, the branches are going to go like this. See how the directrix line is behind the parabola and the focus point is inside the parabola. Same distance from the center. 4 to the focus, back 4 to the directrix. Where we get the 4? Right there. It's the number next to the original 4 in the equation, right? When we started with 16, we factor out a 4. And then that other number next to the 4 we factored out, which also happens to be a 4 in our case, is the A. And that's super important because that's how far from the center to the focus and backwards to the directrix line. Now, the directrix line is just that. It's a line. It's not a point. It's a dotted line. So we need to give the equation of a line. What is that? Well, this is the x-axis and this is the y. Which axis is that dotted line, that directrix line, which directs the graph? And which axis is it hitting? Does it hit the x-axis or does it hit the y? Well, right here, it hits the x-axis. So it's going to be x equals -4. It goes through the x-axis at -4. So the equation of it, remember, we need an equation, not a point. The directrix line is not a point, it's a line. So you need the equation of a line. And it goes through the x-axis at -4. So it's x equals -4.
Mr. Herring.
He answered the important questions. Let's go ahead and graph the thing though, even though it's not specifically required on this one, it will be in other ones. So let's graph. So how do we graph? Well, that's what I'm telling you down here in the notes. Again, it's all about these notes. Find 2 points. On the branches called Latus Rectum are 2 points on the branches are this right here. For specific, see the pictures. They are always at the focus depth inside the branches, but twice the focal distance away from the focus. And you can see on this graph right here, right there's a Latus Rectum point, and right there's a Latus Rectum point. So there they are. Let's see it. So basically, the branches are going to go like this, and then right at this focal depth. Remember, this is the focus right here, right? At the focal depth, which is what? 4 away from the center. You double that. See that? See it right here? A and 2A. A and -2A. Double it. That's what these notes are saying. Right? It's A and 2A. Focal depth, but twice the focal distance away from the focus. 2A. So we got to go twice. So I'm going to go, okay. So this is over 4. So then I'm going to go, this is 4. So I'm going to go 8 and -8. There it is. And the other way, I just went up 8. And I'm going to go down 8. 1, 2, 3, 4, 6, 7, 8. From the focus. See how I'm going from the focus? Double the focal length. 2 times 4. The focus is 4 out. And then I double that, 8, up and down. Those are points that the real parabola actually goes through. Let me see if I can draw the thing in the tool. Kind of missed. Yeah, I'm not going to use the tool. There we go.
So, Mr. Heron, the A is the one in front of the parentheses, right? Just to make that clear.
It does, front and back doesn't matter, right? Right? If I go 3 times 4 or 4 times 3, that's we can't count on that. We say it's the number next to 4. It's not the 4 itself. It's the number next to 4. That's the way we want to say it.
So it's not the 4 we factored out.
Right. It's
Okay.
not the 4 we factored out. Right. And that's what we see here in the words. Where, well, I guess I didn't really say it too clearly. Yeah, it's not the 4. Yep, it's the number next to 4. All right. So then those are, let me do the other one down there. Let me do this one. Yeah, that worked out. Here we go. So that's a much better parabola. So notice how it went right through those lattice rectum points. What are those points? Well, that one's over 4 up 8. This one's over 4 down 8. Now, they don't ask us for those, but there they are. That's the parabola. Again, do you notice that the lattice rectum points, the 2 dots, and why do we know? It tells how wide the branches are, because sometimes parabolas are real narrow, sometimes they're real wide, sometimes they're in between. You know, how do we know exactly how wide? We know it's going to the right. We know it's branches to the right. We know the Directrix line is back here and the focus point's in here, but how wide do we make the branches? That's why we care about those 2 points called lattice rectum points. And again, how do you find them? You go out to the focus and at his depth, double that. So it was 4 to the focus. So I went 8 and 8, up 8, down 8. And I found the 2 lattice rectum points. And so that A is super important. And so yeah, that's a good clarifying question. The A is the number next to the 4. I know mine's weird because they're both 4. But A is the number next to the 4. And so there we go.